Okay, so today we're going to start Unit 8. I'm going to start with Lesson 8.2 because 8.1 was in Unit 7. So if you remember the very end of Unit 7 with 8.1, we learned how to solve trig functions, and we used graphs to solve them. We're going to learn something about inverse functions to solve trig functions now. I am quite aware that some of you are already familiar with inverse functions, which is nice. So let's talk about what inverse functions are and what they do. So first of all, with the conceptual side of things, okay, so an inverse basically says if I take the inverse of a function, I end up with itself. Now with sine graphs, you can only do this within certain windows, okay? So in this case, the inverse of sine of u only equals itself u if u is between negative pi over 2 and pi over 2. And this has to do with because of the way that if you were to take the inverse, it means that it's 1 to 1, and so if you were to flip the sine graph on its side, it will only be 1 to 1 in certain areas. So it's only from negative pi over 2 to pi over 2. Now, the other direction, if I take sine of the inverse of sine, it's only from negative 1 to 1. So realize that these are your bounds. If you end up with something that you're trying to do that's outside of these boundaries, it won't work. If you get an error on your calculator, then chances are it's because of one of these things. So here's how this works. If for every v with between negative 1 and 1, okay, and there's a unique number u from negative pi over 2 to pi over 2, whose inverse is exactly that number, okay? Only when sine u equals b. I know this sounds confusing, but really it's not. It's about being able to take inverses so I can solve. So let's go ahead and look at some examples. That will be an easier way to do it. I think we have to go into cosine first, though. Yeah. So cosine are bound by 0 and pi, and also by negative 1 and 1. So just realize that. These are the boundaries. So it's the exact same idea with cosine as it is with sine. Tangent is a little different. And you'll have all of these in a chart, so don't freak out quite yet. All right. So tangent is, oops, I wanted to pause and I skipped all the way forward. All right, let's go back. Tangent. There's tangent. Okay. So tangent is from negative pi over 2 to pi over 2, and the flip side of it works for everything. Okay, because remember that the range for tangent is all real numbers. So. So here's an example. I keep pushing the wrong button. I'm sorry. There we go. Okay. So cosine of negative 1 is 0. Pretty much, this is a calculator issue. All right. Well, with this one, you should know what it is. So the cosine is basically saying the cosine of what is 0, and we should know that. That's pi over 2. And the sine of what is negative 1. Okay, that's another one that you should know. All right. Sine of but let's go ahead. I have these written down. So the cosine of x equals 0. What is that? And that's pi over 2. If you have the opportunity to be able to solve it without a calculator like this, I want the answer in pi's. Otherwise, you can throw them in a calculator and it'll give you the answer. So sine of negative 1. Now, they're going to put it in a certain way that's not quite like the unit circle. So the sine of negative 1. I put this in here to let you realize those are basically the same thing, but 3 pi over 2 is out of the range. So same thing here, 3 pi over 2 is out of the negative pi over 2 to pi over 2, but negative pi over 2 is that, and they're the same thing. So, okay. So now you're going to do these on your own, all right? The sine of negative 1 of 1/2. Realize that your bounds are from negative pi over 2 to pi over 2. So let's look at the solutions, okay? So from negative pi over 2, whose sine is 1/2, okay? And that would be pi over 6. So pi over 6 is the answer. We don't have to do the infinite answers because, again, it's looking only on this interval. Okay, and then this one is negative pi over 4 because negative root 2 over 2 is negative pi over 4. Now, I know most of you want to say 7 pi over 4, but that's not in this interval. And if you think about the unit circle, if I go backwards pi over 4, it's the same thing. Alright, so then it gets nicer here, where we use a calculator to solve the problem. So you simply, this is so easy, seriously. Your inverse buttons are right above your actual buttons, so the cosine inverse, it would be second cosine. So I do cosine inverse of 0.76, throw it in the calculator, and I end up with okay, going to the calculator. And it's an approximate because I'm not going to write the whole decimal out. I can't. It's 0.7075. Alright, now you're going to do this one on your own. Again, throw it in your calculator. You should get the answer. And I get 2.2523. Simple, right? Now moving on. Alright. So now, these ones get a little more difficult because you have to find the values without using a calculator, meaning I want these in terms of pi over 2. So you're going to always work inside out. Okay, so you find the inside first, and then you find the inverse of that. Or if the inverse is on the inside, you find that first. Keep in mind your boundaries. So the first one, we're going to find the sine of pi over 6, and then we're going to take the inverse of that. So the sine of pi over 6, you remember, okay, is 1/2, okay, unit circle. Now the cosine of what equals 1/2? All right, and again, look in your unit circle, and then that would be pi over 3. This one's an easy one. This one's a little trickier. You have to think about the Pythagorean theorem. So we're going to let u, and I say this, when I put this let u equals, all right, I put this in here because we need a variable to put in here, and this will happen quite a bit. You'll notice in the next few sections where we won't be able to solve it because there's too many things going on, so we'll just put that whole thing as a variable to make it easier to solve. So we're going to say u is this inverse sine of 3/5, and then we're going to find that first before I do anything else. So the sine of what, or the sine of u equals 3/5. And if you think about Pythagorean theorem, okay, sine is, well, first of all, let's go back to our SOHCAHTOA. Sine is opposite over hypotenuse. So this is my opposite, this is my hypotenuse, and I'm missing a side. So 3 squared plus x squared equals 5 squared, and I can then solve for x. So x equals 4. So, so then the tangent of u is going to equal 3/4. Because 3 is the opposite, and 4 is the adjacent. Now, again, this is a really weird one, okay? And I want you to realize that this is very different. So let's talk through this one more time to see what I did. So the very first thing I did was I said, okay, we're going to let this whole thing equal u. All right? So if I have a triangle, well, first of all, so I said sine u equals 3/5, and I have this triangle now, where I know that 5 is the hypotenuse, because the SOHCAHTOA says it's opposite over hypotenuse. All right? So of this angle here, this u, all right, this is my opposite, and this is my hypotenuse. I use Pythagorean theorem to find my opposite, or my adjacent. Now, if I know that the sine is opposite over hypotenuse, I know that tangent is opposite over adjacent, SOHCAHTOA, right? So I could say that tangent of u equals the opposite over adjacent, and I do not need to know what u is. So I solved this whole thing without knowing this angle, and I still have my answer, because my answer was what is the tangent of the inverse of sine of 3/5. So it doesn't matter what the angle is. It doesn't matter what u is. I know that this is 3/4 because the tangent of this same angle right here is the opposite over adjacent. Okay? Now you have a practice problem that's just like the one I just did. Okay? So I want you to try this one on your own. The tangent, okay, keep in mind, so go ahead and hit tangent u equals radical 5 over 2. Set up your triangle, and then take cosine of the same thing to find that angle. So pause the video, try it on your own, and we'll look at the solution. Okay, so here's our solution. So tangent, so they did let tangent of u, that the inverse of tangent, radical 5 over 2 equals u, so tangent of u equals radical 5 over 2. So this is positive, so we know that this is opposite over adjacent, opposite over adjacent. And I would use the Pythagorean theorem, okay? 2 squared plus the square root of 5 squared is 9, the square root of that is 3. So then the cosine is adjacent over hypotenuse, so I have adjacent over hypotenuse is 2/3, and that's my answer. So again, I know this is a little bizarre, but not that hard. And I will see you tomorrow, and I will answer any questions you have. This is brand new stuff, so this I imagine I will have quite a few questions. So see you tomorrow.